All right. Hello, everyone. My name is Ben Murphy, and I'm going to give a talk that I think we've been needing to have for a while. I would say it's about time for this talk, and this talk is about time. So I'm here representing GridPoint, and we'll go through some of the very important stuff here. I'm not corporate, so I can't tell you what our mission statement is in the precise words. Depending on who you ask, you're going to get explanations like site automation, energy management, comfort management. The businesses, our clients, tend to be kind of medium-sized buildings. Your shops, your restaurants, Walgreens, things of that nature. And the big player for our company is thermostats and HVACs. Those guys consume a lot of energy, and we're in the energy savings business. So the balance that we need to be striking is how comfortable are people who are in this building. We don't want people burning up in a restaurant, but we also don't want to be burning up the energy bill either. And this is actually going to be kind of really in play for this talk about time. So you hear the phrase time, and we're here at a software convention. We're talking about software engineering, so it's about date time, right? I think we've all probably heard at least one of those talks about how it's a nightmare to roll your own date time library, right? You don't do it, you use whatever you're given. Thankfully, this is not that talk. This is not about date time. It is about a slightly less evil, but I think sneakily tricky topic. And what we're going to be talking about today is event scheduling. We're going to be talking about event scheduling, particularly at the human scale. We're not going to be talking about process scheduling or things of that nature. We're talking about the world that you and I live in. And the world that we live in is pretty predictable. Most of the buildings that you're going to set foot in have a schedule that looks like this: Monday to Friday, 8 to 5, Saturday, limited hours, Sunday closed. Not precisely, but generally speaking, this is kind of the world in which you and I live and operate. It's a world of times and the concept of dates. You and I don't particularly live in the world of capital D date, capital T time, date times. But it is still very predictable, and computers like predictable things. However, humans, very unpredictable. If you've ever tried to organize anything that involves more than yourself, a D&D campaign, pickup sports, the nerves meetup, if your fire alarm has gone off, we manipulate our schedules all the time. They get interrupted, extended, canceled, any number of things. We build very predictable schedules, and then we tear them to shreds at every available opportunity. So how do we manage this, right? What's the secret here to reconciling the unpredictability of human life and the very predictable ways that we try to do these things in code? So all of this that I've described so far kind of falls under what we call the recurring schedule, right? This is our general mode of operation. Every week we're going to want to do the same thing. It's not exactly a date time. It's not exactly a date. It's kind of a time, right? We kind of have this in-between format where really it's day of week plus time, right? And it's going to look something like this: Monday, Tuesday, Wednesday, so on and so forth. And maybe you just don't have anything at all for Sunday, right? So if we're in our nerve system and we're talking to the cloud platform, how do we get that kind of weekly information down to our nerve system from the cloud? Well, the naive solution here is we say, all right, cloud platform, it's the beginning of a week. Send me all the things that I need to do this week. And the cloud says, all right, here you go. For the week of May 5th, we're going to do these things on all of these days. And every week you do that. And that works, I suppose. But what if you have a week-long internet outage? What if someone goes into the platform and changes the schedule 5 times within 5 minutes? How often do you really want to be sending this kind of information down? And if you can't send it down, how tolerant do you want to be to running out of time, right? Do you have restrictions and limitations to this where you say, well, enough is enough, we tried our best? A slightly less naive solution here might be we don't send date times. We send the week, and every week we derive the week. And we keep it in this kind of day of week plus time, because day of week is entirely agnostic about the particular date that you're on. You can figure that out on the fly in real time. So, a single time you get this message and you say, all right, I can handle it from here. I'm going to keep on figuring out which date Wednesday is. And you might have something that kind of ends up looking like this, a little bit elixir-y, right? We've got the day of week that we care about, and we have the time that an event begins, and then we have the time that the event ends. And once you get here, the burning question, the important question is, what day of week am I currently at, and what does the next 7 days, or really the next however many days, what do the future upcoming days look like? But the tricky thing there, right, is that we're not going to begin our execution guaranteed every day, Monday at midnight. This could happen at any point in time. We lose power, any number of things. So it's a little bit of a puzzle. So we're going to look at some code here. I am going to say I wrote this code like 2 days ago without looking at our production code just to see if I could recreate it. So nothing here is probably going to run. So we're going to assume that our schedule kind of has this format. We just have a list of our day of week and our start and end times. So we're going to start by saying, all right, what date is it today? And we also are going to eventually want to know like the actual day of the week. Now, day of week does come in ISO 8601. They have a specification about like, Monday is 1. And so on and so forth. Monday is the start of the week for 8601. So once we know what date today is, and we know our days of the week, we're gonna have to do a little bit of logic here, because we're gonna need to do some comparisons. So we are gonna end up going to a numerical format for our day of the week. So we take this list of tuples that we have here, and we're just a quick little map. Turn those into integers so that we can start doing some real comparisons. And here's where the fun begins. We're going to take this new slightly modified list here, and we're going to split it into 2 parts. We know what day of week we're on today, and we now have everything in a nice, easily comparable format, so we're going to split it. And the first half of the split is going to be all of the days of the week that were before today. And the other side of that split is going to be all the ones after today. If today's Thursday, then we get Monday, Tuesday, Wednesday in the front, and all the rest of them afterwards. And the trick here, the idea here, is that the upcoming week is just going to be those 2 parts, but flipped, right? Everything that we said came before us is in fact going to be happening afterwards. Once we've got them kind of organized the way that we want them to be organized, with today like at the head of our list, then we can start doing some fun stuff and actually converting this into real useful date times that indicate this week. And the magic there is happening in this next recurring instance function, which we're going to get to in a moment. However, unfortunately, I have been told that I need to keep my, oh, my bad, we got a couple other slides here. A different detour is that we hate daylight savings time. It's the worst possible thing to ever be imagined. I know we were talking a little bit about this earlier with time zones. DST is the devil. And the reason it's the devil here is because datetime.new doesn't just return a date time. If you can try to create one, and if it falls within one of these weird date time things, it's going to say, actually, there's 2 date times that could be representing this one that you're telling me about. If we're springing forward, if we're leaping over an hour, and you give it a time that is within that skipped hour, date time says, yeah, sorry, I have a time before and I have a time after. They're really basically the same thing on the clock. So pick one. Or if you have an hour that's repeated, you're falling back, it's going to say, actually, no, I have 2 date times that match this, and you need to pick one of them. And they are separated by an hour of clock time, even though they're the exact same represented time. And for our purposes, we always just choose the second one, regardless of if it's a gap or if it's ambiguous. It just kind of works out that way that it's convenient. And that's part of the difficulty here is these recurring schedules. We don't have a concept of DST. If we're talking about the Kroger down the street, they don't particularly care. 8 a.m. is 8 a.m. So we've got some crusty wrappers here to manage that return. It would be nice if we could like configure the actual datetime module to say, if you run into one of these conflicts, just always pick this one. I don't care. Just give me that one as the return. It's an annoyance. It's not going to kill your code. You are going to get hit with a bug related to it 1 year. I think it's happened to us maybe twice. It's fine. But eventually you learn your lesson. Back on track. So, okay, I guess I see how I did this. Let's take a look at this next recurring instance function. So we've got our weekly events kind of organized the way that we want them to be. So we're again going to take a look at what day today is. And the idea here is that when we're creating the week, we don't want to like waste days. If we have days that are earlier in the week, we don't want them to fall by the wayside just because of some arbitrary ordering of like what a week is. We really want to get the full 7 days here. So we're going to start with today, and we're going to take a look at everything. We're going to take a look at whatever the thing that we're trying to create is. If it happens to fall on a day that is before today in the week, then it's a little bit of modulo, right? We're going to make it seem like it's in front of us because we're just going to add some number of days to whatever today is, and that's going to move us forward in time and allow us to do that for the full 7 days. And then after that, creating your date time is pretty easy from there because you've got the date, and the time format is easy. So you just call your datetime.new, except for the whole deal with daylight savings time. So we got to put it through our crusty little wrapper because who knows what clients are going to schedule their things to look like. But after that, I mean, we're done. It wasn't too painful. And now we can say we have an event. It's going to start. Here's the specific date time for the upcoming week when it happens, and here's the specific end time for it. Great. Now we're going to get to today's hot take because I was told I need to have hot takes in all of my presentations. Here's my hot take for this one, and this one I think is I think it's pretty good. I did think it up like 5 minutes ago. Datetime APIs are fundamentally incomplete until we have some way to represent time in a way that actually matters to humans, right? Until we can do something that deals with days of the week and looking forward into the future, or you can arbitrarily say sometime in the past, in that past's future, same idea. Until we get something like this, date time shaped stuff is just not complete yet. The code that we have here really should be under the hood of something. As an example, this doesn't obviously need to be it. It obviously is not the only such function that's in my mind, but we might want to know on what date does a particular day of the week happen going forward based on some particular other date or some other date time. And that, to me, seems like something useful for humans when you write code that deals with humans. And for the most part, at the end of the day, all of our code is kind of intended to do that. So something like this, it would be nice to have. And I could probably think of like 10, 15 other functions if you give me a minute. But that would be a lot to put into the slides. But that's it. We solve schedules. Great. Any questions? Oh, I have a question. What about Christmas? Christmas does not fall on Monday. Christmas does not fall on Tuesday or Sunday. Christmas moves throughout the year, but it's kind of an important day. So what do we do with that? The recurring schedule by itself isn't enough to really encapsulate the way that we schedule our events and that we organize our lives. We have particular days that break that established convention. Thankfully, Christmas is a pretty well-known date time. It's 12/25 in the year. So that's really not too hard to deal with. So if someone says, oh, I need to schedule something special on this day, well, you just have them send you the date time. You know that date time. You're good to go. Not too much of an issue. Great. All right. So we solve schedules again. Any questions? Ooh, I have another one. What about right now? The fire alarm is going off right now, and I need to change my behavior. This is a little bit different from an exception because it's happening at this exact moment. It's not some kind of future planning. And realistically, things of this nature probably aren't long-lived. For example, you're in a restaurant and it's too hot, so you need to run the cooling for like 30 minutes, right? You don't need to like change the whole way the rest of your day operates. It's just at this exact moment, I need to change my behavior a little bit. And this is different from standard exceptions because we're saying from right now for a little while, change your behavior. But again, right now is a well-known date time. 30 minutes from right now, also a well-known date time. So not too difficult to integrate within our concept of the schedule. So now what we end up with is the schedule that really has multiple layers inside of it. We have overrides, something that's happening at this instant that needs our attention. We have an exception, which is a well-known day or perhaps multiple days where we're going to want to do something different, but like we'll worry about it when we get there. And then at the bottom of it, we have our general expectations for the week, our recurring schedule. Life is good. And I'll make a note here. This type of schedule that we're designing here is implicit. Our schedule is allowed to have gaps in it, right? If the store is open 8 to 5 and there's nothing after 5, then that's okay. We can have gaps in between our known events. And effectively what happens there is we have a fall through and we have nothing. And we don't need to be told about nothing. It's just implied by the lack of something else happening. So really our full schedule ends up looking like this. We've got right now, something's happening. We've got Christmas. We have the rest of the week working the way that we want it to. And if none of these things are happening, then we have some kind of well-known fallback that we say, no one's here, no one's shopping, nobody cares. We can do some final behavior. So we have all these things, and the question is, well, how do we pick the correct one? How do we know if it's an exception or if it's a recurring or if there's an override going on? And another kind of feature of the way that we've designed the scheduling is that it's simple. You get one event that's going on right now. If an override is going on, the recurring schedule is not going on. When it ends, maybe so. And so what you do is you have all of these different categories. You've put them in your database or you have them saved somewhere. And you look through all of them and you find an event or however many events that envelop now. Right? The current moment in time is going to fall in between some start time and some end time. So let's find all of the ones that do so. And from that, we will pick the most important one. Override, and our hierarchy here is in fact a hierarchy, and it's goes from most to least important. So we find the most important one that also envelops now. But here's what it's not that easy. Things get trickier. If it's Christmas Day, or if it's a slightly less important day, there might be some weird conflicts going on where a schedule exception and a recurring event could conflict. And this is kind of where that implicit schedule becomes a bit of a problem. Because what if an exception makes the day shorter than we want it to be? Our normal hours are 8 to 5, but the owner's child is having a birthday party, and so we close at noon. That's special, but our weekly schedule says, well, no, we're going to keep going until 5 p.m. So, we don't want to see the end of a day and then fall through to the next layer that says, actually, no, the day is still going on. Not quite. So kind of two options here. Either the cloud's going to say very explicitly, you have nothing, and it's no longer implied, or we can try to be a little bit more intelligent and we can say, okay, well, if I'm way down here at these lower least priority things, just let me check and see if something, if an exception happened, if something more important happened. And if it did, I'm going to ignore everything else for the rest of the day because whatever that said is done and gone. And so the day is complete. So now our full schedule looks a little bit, it's great. We got some parentheticals in here. Still the same structure, but now we have a caveat that, if something higher up has already occurred, we're not going to fall back to the weekly thing. That's pretty visible, I think. That seems pretty decent. So cooked up a little flowchart here, kind of walking through this. So we begin evaluating the schedule. At any of these stages, we're going to kind of go down the list here. And if we don't have something in one category, we're just going to move on to the next one. So for overrides and exceptions, it's simple. If we have it, we check and see, is it happening now? If it's not happening now, we kind of go back and we just go on to the next one. If it's a recurring schedule, we've got an extra step in here because we need to make sure that we didn't have some other exception that was happening today. It closed half day for Christmas. And additionally, if we have no recurring event, or once we hit no recurring, what we understand here is there are no events. Nothing is supposed to be happening right now. And so in that case, we're going to look into the future and say, all right, well, when is the next thing going to happen? And either based on what we know is currently happening, or when we know the next thing is going to happen, we're going to set a timer for when that thing ends. And that timer is going to go off, and that's going to tell us to do this again. We have figured out what we're doing right now, great, and we're just going to fall asleep for a little while until we know that this thing has ended, and then we'll do it all over. So our initial implementation, kind of how we did this in code, we're working with thermostats and HVAC devices, so we have a process for every thermostat, at a site. And each of those device processes is going to say, all right, I'm schedulable. I need to manage time. So I'm going to spin up a single scheduler process that deals with my schedule and only my schedule. And that scheduler starts up and it will send instructions to me, and I know what to do with those instructions to make it cold at noon, or, to stop making it cold once the place is closed and everyone's gone. On the other side of that, each of these scheduler processes gets start linked, and they immediately go and figure out, okay, what's the event that's going on at this moment? And they talk to their parent and they say, here's what's happening at this moment. And then they go to sleep, and the cycle repeats itself theoretically forever. It kind of looks like this. We have our primary processes here. They're going to start the scheduler, which is going to tell itself to evaluate and sleep until the next evaluation. And the scheduler says, all right, you need to be cooling or heating or running the fan, or so on and so forth. And these schedulers, of important note here, this is not cron tabs. Some of y'all might have been thinking, oh, well, this is just cron jobs, right? Not quite. Because cron really fires events. Cron says, oh, it is 2 p.m. every day. I'm going to do an event at 2 p.m. If you start cron at 2:01, it's not going to say, oh, 2 p.m. was 1 minute ago. Let me go and do that thing. Really, for our use case here, we always need to know what's happening now. Events start and events end, and we need to be aware of that at any point within that time period. So cron jobs are not quite the right tool here. We're significantly more resilient to crashes and the arbitrariness of when we might need to do this. So that's it. We did it. Great. Actually, this time we kind of did it. Unless honestly, I had forgotten about this. It's fine. There's some downsides to this. It's not that it doesn't work. It's just the design is not exactly perfect here. If we're thinking about something like a restaurant, we might have 2 or 3 HVAC units that are running the exact same schedule. So now, with this design of one scheduler per HVAC, we have 3 different processes all running effectively the exact same code. Another issue here is that overrides, really everything kind of has to have an end time. We don't really have the idea of do it forever. And also what to do is really tied in specifically with thermostats, with temperature management. It's not really abstracted yet. And, we're computer scientists, we're software engineers. We like abstracting things. It's the dream. I'll abstract all day. So what's the next iteration look like? Where we went from here was kind of a 2-tier scheduler instead of just a single process that does all of it. And why is that? Well, we might want to support more things. The logic is tightly tied with thermostats and HVAC management. And we don't want to waste these cycles. It's kind of silly, right? If everything's using the same schedule, that should just be a single timer and not like 5 exactly identical timers across 5 different processes. So we ended up with what we kind of called monolithic schedule management, and it comes in 2 tiers. There's the base scheduler, which is tier 1, then there's tier 2, which are specialized schedulers. And to really help support this, we kind of had to drill down into the core of what is an event. And I took a little bit of inspiration from the OTP here. Because we had used digraph before. Great module, great library. If you guys haven't used digraph, use it. It's wonderful. And digraph has this concept of a label. A graph, obviously, vertices and edges, and within digraph, a label is anything. I have a vertex, and I have some collection, some amalgam of data that labels it, and it can be whatever I feel like making it. And an event really ultimately is that. It's a start time, it's an end time, and it's some piece of data that describes the event. And you can be as specific as you want or as generic as you want. You know, it could be closed, or it could be, here's the exact things that I want you to do. You know, it could be a module, it could be a function to run. Really whatever you want. And so the base scheduler within this design handles a couple of things. It does deduplication if multiple schedules are given to it to make sure that it's minimizing the amount of work that it's doing. And it takes care kind of the timer starting that we went over before. And when the timers go off, it takes whatever label is associated with what it's discovered, and it sends that label off to the second tier. Additionally, it's kind of a convenience API for some common functionality related to time manipulation as it relates to schedules. And the tier 2 schedulers honestly aren't really schedulers. It's fine, but their job is more not directly to do with time itself. They're going to do the fetching from the database. They receive a label and they understand what to do with it. You know, if it's a generic thing like closed, well, the tier 2 scheduler's job is to figure out what closed means in terms of operating this facility. It's going to create a single list of events, and then it's going to go to the tier 1 scheduler, and it's going to say, here are your events, go. And it can do whatever it wants to create that list, right? And the idea here is that you might have one for HVAC devices, and you might have another one for, I don't know, like lighting, or some kind of like mechanical thing that's on site, right? And they can all create that list however they feel like is appropriate to them. But it is these tier 2 schedulers ultimately that interact further down the line of, here's how we do the management things that we need to do. And that design is going to kind of look like this. So we have our base scheduler, which still kind of does the evaluation stuff, and it's going to sleep for however long. But then above that, we have our tier 2 scheduler, which is going to say, I want to make a schedule, so I'm going to do the functionality, do whatever I need to do. And then I'm going to tell the base scheduler, here it is. Here's a list of events. I need you to inform me of whenever the next event is going to be happening. And the base scheduler is going to receive it, and it says, great, and it starts the evaluation. And whenever it's time, whenever it determines that a new event is happening, it talks to tier 2, and it says, hey, tier 2, for this particular schedule that you submitted to me, here's the label associated. Do with that what you will. And the tier 2 scheduler says, great, I've received this label. I know what that means. I'm going to go off and talk to all these thermostat processes, and I'm going to say, do your new thermostat thing. And the benefit here is that it's all centralized in a single process. We're a little bit, we're not linked to any of these guys, so we're not as worried about crashes bringing tons of things down and stuff of that nature. Our tier 2 schedulers really are just a translation layer, and the base scheduler is the one that does like scheduling, that cares about time. And some questions arise from this. Once we have this kind of design and we have time management really in its own spot, can we start scheduling things that are not devices, that are not, some kind of physical attribute of wherever we're installed? Could we make temporary changes to like the way that our code runs? Could we schedule in the future some kind of one and done task, some kind of do this event, which is a little bit cron-like behavior, but it's fine. And there's a lot of places that we can go from here. And at this point, we are kind of caught up to the present. So everything from here is further development speculation. One thought that has crossed our head is combine this with some kind of just task runner, right? Some kind of MFA executor. That gives us the ability to have something that's very cron-like. The signal goes out and we run this specific function. And you start getting some cool things in there, like, self-modifying things, or like recursive submission and things of that nature. But cron packages already exist. There's like one or two of them out there for Elixir. They do, I think, at least one of them literally interacts with a cron tab file. And another one is basically is DSL or formatted enough to effectively be one. And also, are there more ways that we can think about time beyond just our recurring weekly schedule and our, one-off kind of specific moments in time? In particular, can we have recurring exceptions, right? Christmas doesn't happen on a specific day of the week, but Christmas happens every year, right? I don't want to say Christmas 2024, Christmas 2025. That's a bit onerous, right? We really would like some kind of medium in between these things. So are there more ways that we can represent the human schedule, and how do we work them into this overall system? Additionally, a big benefit of this two-tiered scheduling system is that it makes it easier for us to examine the schedule from outside. If we only have a single process that has all knowledge of schedule-related things, then it's very simple to just interrogate that process and say, hey, tell me what things are looking like right now, instead of having to go to 50 different processes and combine information from all of them. Some benefits we might get from this, right? We don't want to accept a firmware update if we are open right now. And that tier 2 scheduler tells us, well, what is open? Perhaps we could expedite or delay certain site management things based on what the upcoming schedule looks like. Just a general bird's eye view of what's going on everywhere in this building to make it a little bit easier to, instead of individual processes that are doing their specific procedure, to kind of more overall coordinate between them and manage them at a broader scale. Give our tier 2 schedulers more autonomy. And by that, what I mean is to be able to manage things like this. If it's really hot today, or maybe it's cloudy today, or maybe the stock market is down and everyone is sad, so we know that we're going to close early. So let's just take care of that, right? Or, if it's hot today, we know that we need to make things extra cool, and some of these things, right, might not necessarily involve changing the time of things, of when we decide to do something, but they might affect how we interpret what to do. And adding, more decision making within that process could see some pretty interesting things. Another open question here is, can we leverage the OTP more? The timer module gives us this send or reply interval function, which you can just set it up and you can say every however long, send me this specific message. Obviously, beware of time zones, because that is going to get you. Unfortunately, you just can't escape them if you live in the USA. And so, your intervals might end up, getting a little bit weird or messed up, but perhaps it's something that can be leveraged. Perhaps there are other uses for it. And I forget. Yes, most importantly, the most important thing probably that we can do here is to have a good time. And that's all I have for you guys.
Questions for Ben?
Are you able to handle really, different things that I didn't hear, like election day, the first Tuesday after the first Monday, or the fourth Monday for holidays, or like your fifth? And dare I ask, blue moons, the second full moon in a month, or Easter, which is dependent on both the heliocentric and the geocentric stuff.
So here's my answer to that. I'm not going to go all the way back through the slides. You remember the part where I was talking about don't roll your own date time? And I was like, how this is not quite that presentation, but there's some secret insidiousness. Yeah, that's your question. Yeah, and some of those things. So So some calculations, right? For example, sunrise and sunset, right? Like, there are mathematical calculations that you can do for some of these things. And like the cycles of the moon as well. And so the answer to that question is it's doable, but at what cost? And there are some other ones, yeah, right, like election day or Easter, where it gets really complex. And we personally, our clients don't really have need for that kind of support, or if they do, like for Easter, right, they'll just look at the calendar and say, oh well, this year Easter's on this day, so we'll put in specifically for that day. But there's no reason that support for those things couldn't be added. It is at that point, yeah, just kind of a question of development time and resource usage. Yeah.
It's a you me situation. Great talk, thank you. And we have bits of access control, which is very time intensive, and we have a
Mhm.
lot of similar logic. So it's pretty validating to see you came to some of the same
Yeah,
conclusions.
I'm kind of disappointed Frank isn't here because I'd be getting sympathetic looks from him the whole time this talk.
I mean, you're gonna get it more from me than Frank because I have to deal with time more.
Mhm.
But so my actual question is, a lot of this is referential based on the now concept, and
Mhm.
then slightly in the future.
Mhm.
What do you do on your devices to set your now time accurately?
So, I mean, in our case, we have an RTC. We talk to the time server, and we're just based off of that. And our control is entirely from a singular gateway that sends that out to the less intelligent devices.
And is your RTC, is it loaded based on just NTP, or do you have
Yeah,
some favorite time servers you go to?
I think we might be configured for specific ones, but yeah, we talk to some NTP server, and obviously, we have a battery backed RTC in there. So like, worst case scenario, like we have something close enough.
Perfect.
Hi. My question is mostly about edge cases.
Oh
Like,
boy.
have you rolled out your product in like Arizona or in China, and then what blew up?
Not China. I don't know about Arizona. Theoretically, I don't specifically know. Are you talking about like half hour time zones?
Well, half-hour time zones, non-daylight savings, no time zones. Like,
Right. So a lot of that, I think the answer to that one is Elixir date time takes care of it, fingers crossed. And if it doesn't, but I think that's mostly within the Elixir standard library.
okay. And then for the real-time clock that you have, is that self-calibrating? Like, do you know the accuracy of that, or is that like I hope it's okay?
Um, Personally, I hope it's okay. Other members of the team, perhaps not. But generally the NTP time servers do their job.
You don't expect to get disconnected from the internet.
If we do get disconnected from the internet, not for long enough to like die because of RTC issues.
Yeah, that RTC is set with NTP, if I recall correctly.
Yeah, it is.
Yeah.
Just wanted to throw out a couple comments. Great talk, by the way. I don't know if anybody's familiar with Jeff Geerling. He runs a couple blogs and YouTube channels, mostly about Raspberry Pi, but he's done a couple series of episodes talking about timing, particularly if you've got an application that requires very precise time or sub-second time, like down to the nanosecond level. Maybe you're doing audio or video synchronization. There's a lot to learn there as well. That doesn't solve all the problems with like time stamping things like logs, especially when you have daylight savings time or you're moving through time zones. That's a problem I think needs to be addressed. Also, there's situations where things like daylight or sunrise or sunset don't occur because of where you're at on the
Oh
earth.
yes.
So your location has to be somewhat relevant to now as part of this, depending on your application, and that just makes it n squared
Yes.
more complicated.
Yes, there is an entire excised portion of this talk where I had originally had talking about lighting control because that's a feature that we have developed somewhat recently, and Right, because people care about turning the lights on or off at sunrise and sunset. And we ended up kind of just making like a blanket product decision of like, if they're too far north or south, just don't let them do sunrise sunset, because no, they can figure it out. They're, at that point, they're probably used to it, to being special in that regard. Because yes, it's a nightmare. Oh no.
Hello.
Hello.
Have you guys solved the security problem and disallowing basically or fixing the security so that your customer networks aren't intercepting NTP packets and injecting stuff into it that might disrupt the actual time functionality of your firmware?
I think the look on my face answered that question. Um, yes. So for those not in the know, NTP is basically plain text. And you can absolutely, like, someone can just sit in the middle and do whatever they feel like with those packets. It's not fun. And we have had like one instance, like a singular site for an existing client, like a single one of their sites somehow was like man in the middling our NTP and like telling us that like we had a leap second that we needed to resolve, and like it was something was just always invalid, and like I think it was just a completely malformed packet that they were somehow like screwing it up for us, and obviously that could be used more nefariously. um, this is not an NTP security talk, so nice try.
Anyone else?
Cool. Thank you, Ben.
Awesome.